Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will work on unique paths. So, for brute force approach, we will use recursion, and the problem states that we are having a robot m by n grid, and initially it is at the top left corner. This robot tries to move to the bottom right corner, and this robot can only move either down or towards its right. We need to find the unique paths that the robot can take to reach this bottom right corner. So for the brute force approach, let's return the number of paths passing I, J, M and N. Let's implement this. The return type would be int, returning the number of unique paths, and let's implement this paths method where int I, int j, int m, int n. Now we will check. So the base conditions would be if it reaches the boundary, then we need to return 0. If it reached the destination, then we will return 1. First, let's write for the destination. Destination is nothing but if I is equals to, since this is m by n matrix, if I is equals to m minus 1 and j equals to n minus 1, which means this cell, if it reaches that, then we will return 1, which means that is one path. Now we will check if it is out of bound. For that, if I is greater than or equals to m, or j is greater than or equals to n, if we move out either in row or column, then we will return 0 because it crossed the boundaries. Otherwise we will return paths and passing the next index I, j, m and n plus paths of I, j plus 1 this time, m and n. So yeah, let's run the code. It is accepted. So this has some overlapping subproblems because the recursion recomputes the same I comma j many times, so the time complexity is exponential, which is roughly 2 power m plus n, and the space complexity would be O of m plus n due to the recursion depth. So this works only for tiny grids, and this times out for maybe larger grids. So let's write a optimized implementation using DP for this. Okay, now in DP, let's take top-down approach now. Maybe we would need a DP matrix or 2D array, integers of type, maybe we will call memoization, memo, and this is of type integer, and the sizes would be m and n. Now we will return the paths. Return paths. We'll pass 0 index I, j, m, n, and we will pass dp as well. Now let's implement this. The return type would be int paths. We'll pass int I, int j, int m, int n, and memo. This is of type integer. Now Now we similar to the previous solution, we are just copy pasting. If it reaches the boundary, then we will return 1. If it is greater than or equals to 0, if it is greater than or equals to m, or if it is, if it crosses the boundary, then we will return 0. Now before checking, we will first check if this memo of I and j is not equals to null. Then we will straight away return memo of I and j. Okay, otherwise we will update the matrix I at index I and j with the parts of I plus 1, j, m, n and memo plus the parts of I, j plus 1, m, n and memo. And then we will return I and j. Yeah, let's run the code. This is similar to the previous implementation, just that we are what is this? Oh, we should pass memo. This is similar to the previous implementation, just that we are checking before calculating, and if it is not already calculated, then we are updating the current matrix. So for this, the time complexity would be O of m into n, because each cell is computed only once, and the space complexity would be O of m into n, because we are using a memo table in the form of a 2D array, plus O of m plus n recursion stack. Now we also have bottom-up approach or tabulation. Where we need a DP array m and n. Initially, let's update this initial cell with 1. Now for I from 0 till m and j from 0 till n, we will check if this is valid, which means greater than 0. Then we will update dp of I of j plus equals to dp of I minus 1 and j, and for columns we are checking if it is valid, and we will say j plus equals to p of I and j minus 1. So the answer will be present at the last cell. So this would be m minus 1 and n minus 1. Let's run the code. Yes, so it is accepted. So we can also optimize the space further by taking a 1D array of size n, and for, let's say, j equals to 0, j less than n, j plus plus, let's update this dp of j with 1 in all the cells. And for int I equals to 1, I less than m, I plus plus, and for int j1, j less than n j plus plus, we will update dp of j with the current j plus j minus 1, and at the end we will return dp of n minus 1. Let's run the code. So here the space complexity would be O of n because we are using only 1D array. So that's how we optimized the space, but the time complexity would be O of n square. So yeah, that is it for today's problem, and I'll see you in the next one.